Thanks for watching my video today. Let's evaluate this, a class of logarithmic integral. Okay, then is the integral from 0 to 1 x log x upon x square minus 1 dx, where this log x is natural log. Okay, so which is equal to, let's try to prove that, which is pi square over 24. Now let's give our solution. So let's square it or integral to be I, so which is I equal to integral from 0 to 1 x log x upon x square minus 1 dx. Now since here is x, okay, we can use substitution method, right? So which is put x square minus 1 equal to u. Then if the differentiation is differentiation of x square is 2x, right, dx, and differentiation of 1 is 0, right? So we remember 2x dx, which is du. Now here in is x and dx, right? X dx equal to 1 by 2 du. Now our integral I is equal to integral from, when you put 0, okay, in place of x, when x tends to 0, then u will tend to negative 1, right? 0 minus 1 is minus 1. When x tends to 1, so 1 square is 1, 1 minus 1 is 0, so in is 0. U will tend to 0. Log of 1 is x. Let's find out x here. X square minus 1 equal to u, right? X square equal to 1 plus u. X is square root of 1 plus u. Actually this will be plus minus, okay, but we neglect minus 1, okay. So x is square root of 1 plus u. Therefore log of 1 plus u. X is 1 plus u. And x dx is what? X dx is 1 by 2 du. 1 by 2 du. X square minus 1 is u. So u, which is equal to 1 by 2 is constant. So 1 by 2 integral from minus 1 to 0. Log of this square root is nothing but 1 plus u to the power 1 by 2, right? So that this is under the log, okay. Log of 1 plus u to the power 1 by 2 upon u du. And by using that, log of x to the n is n log x, right? N log x. Therefore I is equal to 1 by 2, and this is 1 by 2 coming here, okay. 1 by 2 because of constant. So integral from minus 1 to 0 log 1 plus u upon u du. And this integral is already evaluated. You can check out. Anyway, let's evaluate here again. So this is 1 by 4, right? Integral from minus 1 to 0 log 1 plus u upon u du. Now by using the expansion of log 1 plus u, I is equal to 1 by 4, integral from minus 1 to 0, sum from n equal to 1 to infinity, minus 1 to the n minus 1, u to the n upon n. This part is expansion of log, okay, and du upon u, which is 1 by 4. Now changing the integral and summation. So 1 by 4 sum from n equal to 1 to infinity, minus 1 to the n minus 1 upon n, integral from minus 1 to 0, u to the n minus 1, right? This and this is power 1, so u to the n minus 1 du. Now integrate that. I equal to 1 by 4 sum from n equal to 1 to infinity, minus 1 to the n minus 1 upon n, u to the n upon n, right? Which is 1 by 4 sum from n equal to 1 to infinity, minus 1 to the n minus 1 upon this n and n square. So and u to the n from minus 1 to 1, 0. So which is 1 by 4 sum from n equal to 1 to infinity, minus 1 to the n minus 1 upon n square. So if you plug the value here, 0 to the n, okay, this is actually 0 to the n, and 0 to the n is just 1, 0, right? Minus, if you plug here, in place of u minus 1 to the n, so which is 1 by 4 sum from n equal to 1 to infinity, minus 1 to the n minus 1 upon n square. 0 minus something is just this one, right? So this one I can put in as minus 1 to the n plus 1, right? Here you can plug here 1, right, using the exponential law. So which is 1 by 4 sum from n equal to 1 to infinity, by using exponential law again. So these two can combine it, minus 1 to the n minus 1 plus n plus 1 by n square. So here minus 1 and 1 cancel out. 1 by 4 sum from n equal to 1 to infinity, minus 1 to the n plus n is 2n, right, upon n square. So which is 1 by 4 sum from n equal to 1 to infinity, minus 1 to the square, minus 1 square whole n, right, upon n square. I can write this by using exponential law. Therefore 1 by 4 sum from n equal to 1 to infinity, minus 1 square is same as minus 1 into minus 1, so this is plus 1, right? Therefore 1 to the n upon n square. So 1 to the n is you plug 1 2 3, it will be always positive, right? Which is 1 by 4 sum from n equal to 1 to infinity 1 upon n square. So which is, this is a well-known identity, right? So this is called Bezier problem, okay, which is 1 by 4 zeta of 2, right? Because of Euler we have this, okay, zeta of 2, which is 1 by 4 pi square over 6. So combine it, I equal to pi square over 24, right? Therefore our integral is integral from 0 to 1 x log x upon x square minus 1 dx is pi square over 24.